Hello. In this video, I have tried to explain some of the solution to the selected problems on current electricity. They are circuit problems. Let us see. If you have any query after seeing this video, you may contact me on this mail or on this phone number. So before started solving the question, let us now first of all see what are the basic formula that we would be requiring for understanding these problems. Okay, so the first basic law that we have to remember is our Ohm's law. V is equal to I multiplied by R, where V is the potential difference, I is the current flowing, R is the resistance of the circuit. In addition to this, what we have is an EMF of the cell. EMF is the open circuit potential difference across the terminals of the cell, and the relation between this EMF and the potential difference is this E is equal to V plus current multiplied by the internal resistance. The small r is the internal resistance, which is representing the resistance of the electrolyte of the cell that we are using. So if I combine these two relations, what I have is the expression for the current is I is equal to E upon small r plus capital R. Okay, or you may also write this V minus or this E minus V is equal to IR, and this IR is also called as the potential drop or also called as the back EMF, that is representing the potential difference across the resistance of the electrolyte over there. Okay, so these are the basic formulae that are to be kept in mind while solving the question. So in this series, I have taken first question, in which I have been given two cells, each of EMF 2 volt. An ammeter has been connected over here. One key is here. Let us close this key. And I have been given two resistors, 4 ohm each, and they are connected in this pattern. Okay, so you can see from here, both of them are connected in parallel. Okay, because they are connected, one end of both the resistors it is connected to point P, the second it is connected to the point Q. So what has been asked in this question is we have to find the equivalent resistance between the points P and Q. Then we have to show the reading of this ammeter, and then we have to find the electrical power between the point P and the Q. Okay, so let's now start with the first part of this. That is, I have to find the resistance between the points P and Q. So we can see that they both are connected in parallel. So we know that in parallel we calculate the equivalent, like 1 by R is equal to 1 by R1 plus 1 by R2, or simply we can write it R is equal to R1 R2 upon R1 plus R2. So you can see that that would be R1 R2 means 4 into 4 divided by 4 plus 4, that would be equal to 16 upon 8, that is equal to 2. So the equivalent resistance between the points P and Q is 2 ohm. So my first part has been solved. Now in the second part, he is asking me the reading shown by the ammeter. Okay, that is, I want to find what is the current that is flowing through this circuit. So I know that formula, I is equal to E divided by R plus R. Okay, what this capital R is the total external resistance, which in this case is 2 ohm, and there is no value of the internal resistance given here, so we may assume it to be equal to 0. So this small r can be assumed to be equal to 0 over here. They can see that my I would simply be equal to E. Now total EMF is, since I have been given two cells which are connected in series and each cell is having an EMF of 2 volt, therefore the total EMF of the battery which is formed there would be equal to 4 volt. Okay, so 4 volt divided by small r is 0, and what is capital R here? Capital R is 2 ohm, that is total external resistance is 2 ohm. You can see from here this volt by ohm is nothing but ampere, so I have the current is equal to 2 ampere. Okay, so the answer to the second part is 2 ampere. Now the third part of this same question, I have to find the electrical power between the point P and Q. Okay, So you can see from here, this P is equal to, we know that there are many formula. P is equal to V into I, P is equal to I square R, P is equal to V square upon R. Okay, so we can use either of the formula. So let us use the simple formula. P is equal to I square multiplied by R. Okay, so I have I is how much? I is equal to 2, that would be equal to 2 square multiplied by R is again 2 ohm. So I would be having 2 square is 4 and 4 into 2 8. So, and the SI unit of power is watt. So the power across this combination of the resistors between P and Q is 8 watt. Similarly, this is another problem in which again 3 cells are connected in series. Okay, now he has given us the total EMF. Okay, 9 volt is the total EMF of the battery which is formed, and this small r is equal to 1 ohm is the internal resistance of the battery, and the 3 resistors now they are given, they are connected like this. A, B and C, they are the resistors which are forming the external resistance of this circuit. So what we have to form here is, what we have to find here is, we have to find the combined resistance between the points B and C. Then we have to find the total resistance between the points A, B and C. Then we have to find the total resistance of the circuit, and then the current in each of the 3 resistors A, B and C. Okay, so let us now try to find the relation or the resistance between the points B and C. So we see that this B and C, they are connected in parallel. Okay, again just similar to that previous question. So this 4 ohm and this 4 ohm, they are connected in parallel. So again the equivalent resistance between these 2 points would be 4 into 4 upon 4 plus 4, that is 4 into 4 16, 16 upon 8 is 16 upon 8 is 2 ohm. Okay, so I have this 2 ohm is the resistance between the points B and C. Now he is asking me the resistance between the points A, B and C. So you can see that this A and the combination of this B and C, they are connected in series. So what I have is the resistance between the points A, B and C, that is this R, A, B, C, would be equal to resistance of this point A is 6 ohm, and the resistance of this BC that we have find is 2 ohm. So it would be equal to 6 plus 2, that is equal to 8 ohm. So this 8 ohm is the total resistance of this circuit, the total external resistance of the circuit over here. Okay. In the third part, he is asking me to find the total resistance of the circuit. Okay, so the total resistance of the circuit is R, which is equal to my internal resistance plus the total external resistance. Okay, that is my small r plus R ABC. So my small r given to me in the question is 1 ohm. This is 1 ohm plus the total resistance I have calculated is 8 ohm. So my total external resistance will become equal to 1 plus 8, that is equal to 9. Okay, so 9 ohm is the total external resistance of the circuit. Okay. Now in this part D, it is very important. He is asking me to find the current through the individual resistors A, B and C. Okay, that is, he is asking me to find the value of IA, IB and IC. These 3 currents I have to find. Okay, so in order to find this, let us find the total current first. Okay, my total current I would be equal to E upon small r plus capital R. Okay, the total resistance of the circuit. You see that E is how much? E is equal to 9 volt, and the total resistance that we have found in this part C is 9 ohm. It is 9 volt upon 9 ohm, that is equal to 1 ampere. So 1 ampere is the total current which is flowing out of this battery. Okay, so this battery is giving me a current of 1 ampere. Now you see that this same 1 ampere current is flowing through this 6 ohm also. Okay, so you can see that the value of this current through this resistor A This IA is equal to what? IA is equal to, I can simply apply Ohm's law. V is equal to I into R. Okay, so this same current is flowing through this 1 ampere. So IA is equal to what? IA is equal to 1 ampere. So the current flowing through this resistor A is 1 ampere. Now you see, when the current is reaching here at this point, and then the current is reaching here, it is dividing into two parts. A part is going to B and the second part is going to C. Okay, going through C. Now you see that the resistors of this point B and C, they are having the same value. Okay, because they are connected in parallel, so they would be having the same amount of current which is flowing. So since the points B and C, they have the same resistance and the same potential difference also, because whenever two resistors they are connected in parallel, they have the same potential difference. You can see that the current would be equally dividing through these two resistors B and C. So when I divide this 1 ampere equally in two parts, what I have is this IB is equal to 1 by 2 ampere and IC also equal to 1 by 2 ampere. Okay. Why have I taken equal division of this current here? Because they are connected in parallel, as well as they have the same value of the resistance. Had it been different, so we could not have divided it equally over. Okay. Now one more question is there. I have been given one battery and a voltmeter is connected across it, which is reading 6 volt. So what I have to find here is, I have to find the combined resistance of this 10 ohm and this R ohm. Okay, I have to find the magnitude of this R and I have to find the current through this R. Now if you see the figure, he has given me the value of current which is flowing through the battery as 1.5 ampere. Okay, so if you see, of course, I can apply my first that Ohm's law, V is equal to IR. So in order to find the total combined resistance of this, let us assume that the total combined resistance of this 10 ohm and this R is equal to RT. Okay, so RT is the total resistance of this combination of 10 ohm and this resistance R. Okay, so if I apply simply my Ohm's law, so this V is equal to how much? V is equal to I into RT, isn't it? I into RT. RT is the total resistance of the circuit. Now you see that what is the value of V given to me? V given to me is 6 volt. Okay. Current value given to me is 1.5 and then it is multiplied by RT. So if I calculate the value of RT from here, RT would be equal to 6 upon 1.5. So if I do this, I would be having equal to 60 by 50 is equal to 4. So the total resistance of this is equal to 4 ohm. So 4 ohm is the total external resistance of this circuit. Now suppose if I see the second part, he is asking me the value of the magnitude of this resistance R. Okay, so you can see from here, this resistance 10 ohm and this resistance R, they are connected in parallel. Okay, so if I take the parallel combination of them, I would be having my total resistance R dash. Okay, R dash is equal to what? R dash is equal to, and R dash would be equal to RT, because that is the total resistance that I am having in the circuit. So this R dash is equal to RT, which is the parallel combination of these two. That would be equal to 10 into R divided by 10 plus R. Okay, why have I written here like this? Because they are connected in parallel. So the combination would be 10R upon 10 plus R. Now you see that in the previous part we calculated the value of RT here. It would be equal to 4 is equal to 10R upon 10 plus R. This is nothing but a simple linear equation. We can solve it. If I cross multiply it over here, I have 40 plus 4R is equal to 10R. Okay, so if I bring this R here, now what I have is 40 is equal to 10R minus 4R is equal to 6R. So R would be equal to 40 by 6, that is equal to 20 by 3. it would be equal to nearly 6.666, so I can approximate to be equal to 6.67 ohm. So the value of this resistance R is equal to 6.67 ohm. Now he is asking me the current which is flowing through this resistance R over here. Okay, in this third part I have to find the current. Now you see that again 1.5 ampere current is flowing over here. Okay, the value of this resistance R that we have calculated is around 20 by 3 ohm. Okay, let us write in fraction only, 20 by 3 ohm. So you can see that these resistors, they are in parallel, so the potential difference across both of these resistors would be equal to 6 volt. Okay, because they are connected in parallel. So in order to calculate the current through this, I can again apply that Ohm's law. Okay, so you can see that my current through this is suppose I dash. Okay, so if the current through this resistor is I dash, so I dash would be equal to V divided by R. Now what is the value of V here? V is equal to 6 volt, and the value of this resistance is 20 by 3. So I can write as 20 divided by 3. So it would be equal to 3 will go in numerator. So 6 into 3 divided by 20. That is 6 3s are 18 divided by 20. That is I have is 9 by 10. That is equal to 0.9 ampere. So the current which is flowing through this resistance R is equal to 0.9 ampere. So in this way we have solved all the three parts of this question. Now this is one question on finding the equivalent resistance. Okay, there is no value of voltage or current is given, but what you have to find is you have to find the resistance between the points B and D and the resistance between the points C and E. Okay, this is a typical network of resistors that I have been given. Okay, let us now see the first part where I have to find the resistance between the points B and D. Let us RBD is the resistance between the points B and D. So in the first part we are interested only in this very part of the circuit. We are not interested in this one. Okay. So if you see this the above portion of this points B and D, you can see that this 4 ohm and this 4 ohm, these two resistors, they would be in series. Okay, because if at all we consider a current which is flowing through this R, the current through both of these resistors would be the same, therefore they would be considered in series. So we know that 4 ohm and 4 ohm, they are in series, therefore the equivalent of them would be equal to 8 ohm. Okay, that is 8 ohm is the equivalent of these two 4 ohm and 4 ohm resistor, and this 8 ohm and this 8 ohm, they are again in parallel. Okay, so this 8 ohm and 8 ohm, they are in parallel. So if we see again the combination, that is 8 into 8 divided by 8 plus 8, it would be equal to 8 into 8 is 64 divided by 16. So 64 upon 16, that is equal to 4. So the resistance between these 2 points B and D is equal to 4. Now in the second part we have to find the resistance between these points C and E. Okay, so in the first part we have calculated the resistance between these 2 points B and D, that is equal to 4 ohm. Okay, so if you consider this figure again, so what I have is this point C, then there is a resistance of 3 ohm. Okay, then I have this is point B and this is point D, and the resistance between these 2 points we calculated equal to 4 ohm, and again I have this 5 ohm resistor. Okay, here is my 5 ohm resistor. Now suppose if you again see these 3 resistors, now they are in series with respect to one another. Okay, so if I calculate the total resistance over here between the points C and E, so this 3 ohm, this 4 ohm and this 5 ohm, they would be in series. So 3 plus 4, 7, 7 plus 5, 12. So the resistance between these 2 points C and E would be equal to 12 ohm. Okay, so in this problem I have to find the equivalent resistance between these 2 points P and Q. Now you see that there are many resistors that are connected over here, and we have to find the equivalent resistance here between the points P and Q. So whenever such questions come, okay, just start solving it from the other end of the network. Okay, for example, here I am starting from these 2 points D and C. So if you see these two resistors, okay, these two resistors, they are said to be connected in series. Okay, so the equivalent resistance, if I say between these 2 points, okay, they are in series, so it would be 5 plus 3, that is equal to 8 ohm. Okay, so 8 ohm is the resistance between these 2 points B and D. So this is 8 ohm. So now you see these 2 points B and E and these 2 points B and D, they are said to be in parallel with respect to one another. Okay, so I have this 8 ohm and this 8 ohm, they are in parallel with respect to one another. So the total resistance of these two 8 ohm resistors is again 8 into 8 upon 8 plus 8, so 64 upon 60, that is again equal to what? 4. Okay, so the total resistance of this complete rectangle, if you see, that is equal to 4 ohm. Okay, now again this 4 ohm and this 6 ohm, they are said to be in series because again the current through them would be the same. Okay, this 6 ohm and this 4 ohm, they are said to be in series. So the total resistance of these two, okay, 6 ohm and 4 ohm, that would be equal to 10 ohm. Okay, so the total resistance of these two would be equal to 10 ohm. Again you consider this 10 ohm and this 5 ohm, they would be in parallel. Okay, so total resistance of these two, 5 and 10, that would be equal to 10 into 5 upon 10 plus 5. So 10 into 5 is 50, right? 50 upon 50. Okay, so 50 divided by 15 ohm. So this 50 by 15 ohm is the total resistance between these 2 points A and F. Okay, and now you see this 50 upon 15 and this 4 ohm, they would be in series. So if I see the total resistance between these points P and Q, what I have is the simple is 4 ohm, it is in series with this 50 divided by 50. So if you calculate this, that would be equal to 15 is my LCM, so it would be 60, 15 into 460 plus 50. So 60 plus 50 is 110. So 110 divided by 15. I know that 15 sevens are 105, and if I keep on solving it, if I divide it, that would be 110 upon 15, that is equal to 7.33 something. Oh, okay. This is the way we have to solve this so-called complicated network. Okay, so here I have tried to explain some of the circuit problems to you. If you have any query, you can anytime contact me through this mail or on this phone number. Thank you.